I must say it's very weird, to get applause when you haven't done anything yet. So, but thank you. So, like he said, my name is Mahmoud Abdelghany, and I'm going to do some talk about some stuff that I learned during this hobby project of mine. So I'm going to start off with an introduction, and I'm not really sure why I'm doing this introduction, because it's not 100% related to the content of the talk, but it's like, giving you some kind of context to why this is. It might not seem very important to. I assume most of the people here are, working for corporations, enterprises, and such, and most of the stuff I'm going to talk about might not seem very important to what we do, myself included. But for games and such, it's kind of important, kind of. So its software is the company that created the actual game, Doom, the actual Doom. So they did a lot of cool games, Wolf, Doom are the Quake, those are the most famous. They did a lot of other cool stuff as well. They open sourced all their games, almost all their games. They were very, involved in the community, very, very involved in the community. They hired a lot from the community itself. So they were one of the first companies. They were very open about how their stuff worked. So they didn't always open source stuff as soon as it came out, naturally. So mostly it's open source like 5 to 10 years later or such. But during that time, they post a lot of information about how you can modify Doom, mod it, or Doom or Wolf or whatever, how you can hack it and such. And people that are most proficient at that kind of stuff, they usually get hired and stuff. So it's cool. So this is, of course, the late 80s, beginning of the 90s. This is a very different era. It didn't have the internet, Stack Overflow. So people, they always reinvented the wheel. It's cool, So that's more actually for myself. But so this the Nerd Rage anecdote. I actually thought about renaming this morning actually to the Unsigned unit test story. But so back in the late 90s, when they open sourced Doom, the first Doom, somebody, everybody was looking through the source code, and somebody came across a piece of the source code where you do the loading of all the assets in the game. And assets, it's like sound files, pictures, models, 3D models and such. And the way the asset loading worked is basically a lazy loading way, So when you get a request for a picture of Doom guy, you just open the big asset file and you just go through it sequentially. Is this a picture? No. Thank you. Is this a picture? No. Is this a picture? No. Is this a picture? No. So, and then until you come across the picture and you load it, and everybody started bitching about it on the internet, 90s internet. So this is not how it's supposed to work. Everybody knows. Every computer science 101 student knows something like this. You load it once and you load it in a hash table, and then okay, I want Doom guy. I look in the hash table. It's like offset 5,700 whatever in the big asset file. But like I said, these guys were very involved in the community, so they were also involved in this discussion, obviously. And they weren't very polite guys, They're just fun guys, this is stupid. No, you guys are stupid. No, you guys suck. No, you guys suck, and that kind of discussion, And basically, it was something like we actually tested how this works, and we know what we're doing. And it turns out they're actually right, So that's the unit test part. So if you look at that small piece of code, this is not the most efficient way to do that specific task, But if you look at the whole game, at the whole loading of a level, for example, this is a very small piece, and it doesn't really matter much how fast this, 10 lines of code, how fast you optimize this, Does your improvement would be 1% or something, and it's pretty expensive, in terms of hardware, for example, because in the 90s, you had like 2 megabytes of RAM, 4 megabytes of RAM, and CPU 66 megahertz, and so I don't know. I like that story, and I keep telling it. I'm not sure why anymore, but yeah. So Doom 3, that's the name of the project, of the Java version. I've been working on it now for about 4 years, I think. It's still a lot of fun. I'm not sure when I'm going to finish it, but it takes a lot of time. Sorry, it was the wrong side to cough, but okay. So yeah, so why this intro? And yeah, I said something before about why this intro, but you know, this table is from, you know, started from a website, but this is basically the evolution of the whole Doom engine over the ages. You know, so the first one, Doom, that is 1991. It's like 40,000 lines of code. And Tech 4, that is Doom 3. That's the one I've been working on. That's like 600,000 lines of code. And so why is this important? So to me, at least, you know. So to me, this was the first time I had to work on something this big on my own. It was very hard to, you know, to know everything at the same time. And I thought at first, you know, maybe it's because I'm just too stupid, you know. But you know, as I you know started watching talks from other game developers and such, and I noticed it's a very common pattern. You know, when games grow this large, it's usually, you know, people have like specialties within the game. You know, somebody is specialized in the graphics, not all of the graphics, some parts of the graphics. Somebody is specialized in this, specialized in that. Sorry. So yeah. So yeah, I'm running out of time, so I'm gonna continue. So yeah, so this is a disclaimer. So I'm not an expert. Obviously, I didn't work for id Software. I didn't work on the original Doom. I'm also not a Java expert. Yeah, I program Java full time for now. I think like 15 years. But I'm not one of the, you know, architects or whatever. So I might say something that is wrong. Some of my examples might be wrong. So test it out, check it out, and excuse any language. So yeah, so the way I structured this talk is, at first, this is like some stuff I really liked in the original Doom. And when I came to port it to Java, it was hell, you know. So it's like stuff that's better, in my opinion at least, it's better in C++ than in Java, you know. And yeah, just bear with me, okay? So this is an awesome picture, you know. So where I come from, this is normal. Where you come from, obviously not, but sure. So yeah, this is the overloading. This is my picture for overloading. And yeah, so operator overloading. So I think the last talk, the talk before that, somebody mentioned something like you have to get involved in the community, you know. Somewhere in time, Mark Reinhold said, we will never have lambdas in Java, and behold, we have lambdas in Java. So if you get involved in the community, some stuff might happen. And I think operator overloading is one of those things that a lot of people are asking for. But it's very domain specific, you know. So for most of what we do, you know, enterprise stuff, nobody gives a shit about operator overloading, you know. But you know, people doing math stuff, you know, people maybe, I don't know, graphic stuff, it's very important. So this mighty quote is from a paper Guy Steele wrote ages ago. He was one of the original architects of Java, cool guy. He has a couple of cool talks on YouTube, check them out. And in this paper, he basically says, you know, it's something good, and we want operator overloading. Yeah, and operator overloading, for those who don't really know it, it's basically, you know, in other languages such as C++ and even C#, which we all love, of course. You can define an object and say, okay, if I use the plus sign, for instance, with this object, then do this, you know. So that is operator overloading. We don't have that in Java. And this line of code is from C++, actually. But apparently, this is the root cause why we don't have operator overloading in Java. And if you see the left shift operators, you know, so this is basically C out, that is a standard out, and then some string, and then a variable, and then end line, which is \n or \r, \l, whatever. So this is basically a print line, yeah? But you use, instead of, I don't know, what we do in print line in Java, brackets, and then plus signs or whatever, you use the left shift operator, which is overloaded here for these purposes. And people really hated this idea, I think, and they hated it so much that they decided to exclude it from Java. I'm not sure if this story is 100% true, but I've heard it a couple of times, so yeah. So, yeah. So this is an example of a line of math in the code. So this is, I don't remember what it does exactly, but this is multiplication of some vectors and matrices. You know, basic 3x3 vectors and 3x3 matrices and vectors and that kind of stuff. And these are all these operators are overloaded, you know. So, okay, these are two operators, but these operators are overloaded. So how do you do something like that in Java? So of course, the Java programmer that I am, I opted to create stupid functions, you know, because that's how we do it in Java. And Yeah, it works. It's a lot of hard work. It was a lot of experimentation, but yeah. To me, if you look at these 2 lines of code, to me at least, the one in the middle, it's much more readable than the one at the bottom. I know people disagree with this. Most Java developers actually disagree with this. But trust me, when you do this, when you write 1 line of code, it doesn't really matter. But try doing this for an extended period of time, and you will hate yourself. So, another thing. So this is a very simple example of the stuff you have to think about when you do this kind of stuff. So with operators with math in general, you have something called mathematical operator precedence, and in programming languages you have that as well, operator precedence. So a multiplication should come before an addition, for example, and if you have brackets and you do this stuff, that kind of stuff. Yeah. So something like this. So this is a very simple example. You multiply 2 matrices and then you add them, add 8. So this is how I wrote this kind of stuff at first. So this is my first. This is actually what happened. But this is absolutely wrong. So anybody who knows anything about operator processes is actually wrong. This is how it should work, how it should be written. You multiply them first and then you add the result. And yeah, this is some syntactic sugar or whatever. So yeah, I'm not sure people can read this, but I was at a presentation and somebody said the exact same thing about Go, Golang. I just love this quote. I'm not sure if you can read it, but it's an awesome, said something like, can't write geometry code without eyes bleeding or something. It's just awesome. So, sorry. Yeah, my favorite operator in Java. So, it's my favorite operator because of this part. Another thing we don't have in Java is unsigned primitives. So, and again, for people who've only programmed in Java, other languages, you can define, for example, an integer, and you can also define an unsigned integer. An integer has, a positive range and a negative range, and an unsigned integer has only a positive range, which is double the size, basically. So that's very helpful for a lot of use cases, not our use cases, not enterprise stuff, but in games, they're cool. So yeah, so the simple solution, to me at least, was to create some, to use this, so if you need an unsigned int, then you use a long, If you need an unsigned long, then yeah, you're fucked. But that's basically it, So this is a very simple solution. The problem is, so it works, of course, this solution, as long as you don't need an unsigned long, it works. But the problem, so this is this is funny to me at least, but this is actually valid Java code. I'm not sure how many people know this, but this is very valid Java code. It will compile. It won't run, of course, but it will compile, because an array size, has to be an integer. It doesn't specify that it has to be a positive integer. Yeah. So yeah, weird stuff, but it will compile. But so the example, it works, but it's not cheap, or it's not as cheap as you might think, So these are some simple benchmarks I did, and like everybody who does benchmarks, you choose the results that serve you best, So these results serve me best. So these are not 100% correct results. So sometimes the double, for example, is faster than the float, because I don't know why and I don't care why, but I only care that sometimes it's slower and that's it. But and the big ints and big decimals, those are notably slower and notably larger in memory, of course. So, and this is the example I used for this benchmark. So, so this operator, I also just added this one. So this is the right shift operator, the unsigned right shift operator. And this is, to me, it feels like, at the last minute somebody decided, okay, we don't need unsigned primitives in Java, and then let's just, give them this operator just in case, they need to shift the last 1 bit, to the right and such. I'm not sure why they did that. And I do like the operator, but it's a different story. Another thing I really like in C++, and it's very hard to do in Java, is how we do immutability in Java. And in C++, it's just, it's just out of the box. And it's easy, and it's readable, and it's just awesome. And as you can see, in C++, they use a const keyword, C-O-N-S-T. I think it stands for constant or something like that. And this keyword is reserved in Java. It doesn't do anything. You're not allowed to use it, but you're also not allowed to create, like a variable with the name const. But in C++, it's just awesome, So the blue example, for example, you see there, you pass const vectors to the function. And what that basically tells the function, or what it tells you as a developer, and it tells the function and the compiler, is you're not allowed to change the constant, the values of that constant within the function, And it's that kind of stuff, It's similar to final, but final you're not allowed to change you're not allowed to reassign it, which is useless, I think, to me at least. So yeah, get dimension, for example, the yellow one, even more awesome. Here you define the function itself as const. And that basically says this is a read-only function. It's not allowed, it doesn't change anything in the body of the object, Awesome stuff. But you don't have that in Java, and you have to be creative and very careful and that kind of stuff. So yeah, final, it does some stuff. So the guys from it's software, so they also realized how awesome const is. And this is from their code, with the link at the bottom, the code style conventions. And they have a lot of, references to how you should use const, and you should use it, and that kind of stuff. And it's pretty awesome. What's next? Size of, yeah. Yeah. So in C++ you can call a size of, and then give it an object or give it a class, basically in Java terms, and it will return, how large it is in memory, how large it should be in memory. It's basically you look at how many ints it has and that kind of stuff, and you return the size. So yeah, in C++, of course, it's very important, because you have to manage your memory, the memory yourself, and you have to do stuff. And in Java, JVM does all that stuff for you. So is that really important? I'm not sure. But the problem in this case, at least, is because this game uses OpenGL. OpenGL needs to know that kind of stuff, So you just have to provide that information. Java has a kind of like a workaround here for this. And it's basically you can do integer.size or integer.bytes or .byte and byte.size and byte.bytes and that kind of stuff, and it will return to you how many bits it is or how many bytes it should be and that kind of stuff. So that's basically what I did here as well. So yeah, again, not very useful for most stuff we do, but it's very essential here. So I'm gonna skip the rant. I usually rant about this a bit, but enum in Java is very weird, and it doesn't really do the basic stuff you expect an enum to do, like in other programming languages. This is all the stuff you can do in enum in Java, which I'm gonna skip because it takes too long. But this is the only thing you can do with an enum in C++, and this is the only thing you can't do, you cannot do with an enum in Java. Which is basically, give an enum a name and a value, and that's it. And the value, out of order values and redundant values and that kind of stuff. You can't do that in Java, You have to be very creative to do that with an enum in Java. So yeah, that's. I usually talk about this much longer, but I'm going to skip this one as well. So pointers. Yeah, pointers are awesome. I know people hate pointers, but they just are awesome. So this is an example. So the game, of course, C++ developers use pointers all the time, and especially in games, and especially in this game, especially in this source code. And this is a very simple example of a pointer. So in this case, if you have something with multiple return values, which we don't have in Java. Other programming languages like Go, for example, have that, and Python have that sucky thing. I don't remember what it's called. Even C# has this, and I'm very saddened when C# has something and Java doesn't, But in C# you can define something as an output parameter, and then you can get it back. And Java doesn't have anything like this. So and then in C++ you just pass pointers and then assign values to the pointers, and that's it. So what's my solution for this in Java? Very simple. Just create one element arrays and just do stuff. So it's ugly, but it costs very little, and it's much easier than writing wrappers and that kind of stuff. Another example, is you can basically cast pointers to other pointers, type-wise, So this is, for example, a pointer to a matrix, a matrix 3 by 3 matrix. That 3 by 3 matrix contains 3 vectors of 3, and each vector contains an x, y, and z. And you basically just return a pointer to the x, which is a float, and then you get a float pointer. And that's it. That's magic. In Java, you need to do what I do there. I just create a new array and return it and do stuff with it, and that's the easiest way I could do this. So, again, you can do that kind of stuff. Skip this one. Oh yeah. So this is the only pointer we have in Java, which is the null pointer exception, which is very curious. And yes, thank you. Yes, and that's how it feels to me. It's just a slap in the face. You get none of the benefits of pointers. We get all this the fucked up stuff about pointers, which is the exceptions of pointers. So yeah, it should be renamed to something else, but that's a different story, a different discussion for something else. So this part is stuff that's the other way around. So this stuff it was in the engine and it was like shitty in the engine, it was shitty in C++, and the Java excluded it, or the Java way was easier and that kind of stuff, So macros, for anybody who knows what macros are, macros suck. Macros are basically, I'm not sure what the history of macros is, but it's basically like something that happens before you compile your C++ program. You can define pieces of text like this with #define, and it will be searched and replaced in your code, and then your code will be compiled. Java doesn't have this, which is very, very good that Java doesn't have this. But C++ has it, and it's heavily used, and it's very heavily used in the engine. And it's just fucked up code, And even the C++ guys themselves, they just hate this. So the C++ guys, the architects of C++, So like Mark Reinhold of C++, which, like Herb Sutter, if anybody knows. People, they don't really like macros, but, everybody uses them. They're so, built in and intrinsic in the language, nobody can remove them. So this is a very simple example from Stack Overflow. Somebody was asking something like, why shouldn't we use macros? And somebody replied with this example. And so this is the example, So this is a square macro. You just give it a parameter and then return the parameter times itself, yeah? And this is how you would use it. And I'm pretty sure, I didn't know, at least, that this is actually what would be compiled, So if you insert 5, for example, as x, you would get something like 30, which is, 30? Yeah, 30, which isn't square of anything, So, yeah. So this is another example of, so this is from an example actually called Death by Macros, which is, it's an article. And this was something, I don't remember the story behind it, but this was something like if somebody wrote very bad macros, it would show him this piece of code and would tell him, okay, rewrite this or debug it or something like that. So everything that's highlighted here is a macro. Even the if statements and the then and the whatever, and all these are macros. This is an actual piece of code. It's not like somebody wrote this to fuck with somebody. No, this is from Unix, I think, or something like that. So, amazing. So yeah, so macros. The problem with macros is they don't really fall anywhere. So the macros are. So a macro can look like a function, but it's not really a function. It can look like a constant, but it's not really a constant. And macros have very fucked up scope. And you can define the same macro multiple times, and it's very, very strange and very, very difficult to do. So this is just to show you. So this is very simple. This is from the actual code, of course. And this, 3 macros within a function. How hard could it be? 3-line function. This unrolls to something like this, which isn't so bad. I've seen worse. I've seen much worse. But it didn't really fit on this slide, so I just chose this one. But the same macro, for example, is used here again. And as you can see, you give absolutely different types, And the same macro works for the different types. The macro doesn't give a shit, It just works. Because it's just text and it gets searched and replaced. So as long as the syntax is still kind of valid, it's valid, it will work. So yeah. Macros are very hard and very difficult, and they suck. This is also something I really hate about C++. This is C++ joke. If you don't understand it, don't care. So, but C++, the same way we in Java, we worship camel case, and I know all of you do. So C++ has something called Hungarian notation. And there's also a story behind it. I don't remember it, so I could make something up. But I think it started on Microsoft or something. And it's basically, it's like descriptive notation, So the idea behind it is, if I read the name of something, I should know everything about it. Everything, So here, for example, this is m_psz name. From the m_, I know that it's a variable, it's a member of something, it's a member of a class, which is useless, I think. From p, I know that it's a pointer. Again, still useless. And from sz, sz, it's a non-terminated string, And then you get the name, which in this case could be name, I'm not sure. So yeah, it just sucks, and you get these unnecessarily long names. If you look at the right corner, or right bottom corner, that's LP, DDS, and whatever and such. But this is also an actual name, and I'm not sure what it does. And there's a lot of hate about Hungarian notation on the internet. It's just weird, It doesn't really get in your way much if you're used to it, but if you're not used to it, like us Java developers, it just sucks. So that kind of stuff. Yeah, I'm not sure, should I hate more about this? Oh yeah, this is my favorite slide actually from the whole presentation, because I didn't make it. So as much as I hate Hungarian notation, camel case can also go overboard. So this is from Stack Overflow, I'm not sure. And this is an actual class name. I think they removed it in recent Java updates or something. And this guy wrote this, which is awesome. Awesome, awesome. So somebody should put this on a t-shirt or something, but it's just beautiful, And it just flows when you read it. Okay, let's just continue. So, is that me? Not really? Okay. So, C++ also has something called a union. And a union is something, it's a very foreign concept for us Java developers. C++ also has something called friend, which I'm not going to hate about, but it's something kind of similar. So a union is basically, how do you describe union? So yeah, so this is union. There. Sorry. So union is basically, you can define like a class with multiple members, but all the members, they overlap in memory. So if the largest member, for example, like in this example, the largest member is an integer, which is 32 bits, then the whole union is 32 bits. And if you call any of the other members, which in this case is, for example, IP2, which is a struct. Struct is basically it's like a class, just see it as a class. It's a class with 4 characters. A character in C++ is 8 bits, not 16 bits like Java. So this is basically, the IP2 is also 32 bits. So they basically overlap in memory. So if you call, for example, A from the IP2, you will call the last 8 bits from IP, which is the last 8 bits of the integer. So this is not really how you should use unions. This is how most people use unions. The real reason why unions exist is something because in the old days, before C++, you had C, and in C you didn't really have inheritance, really. And the union was kind of like I want to say fancy way, but it's more like a fucked way to do inheritance. And I really say this because it's a very, very advanced way to do inheritance. You have to think about it. So if anybody ever, did like assembly programming or such, you think about it. If you did when you did assembly and you created like your bullshit classes and whatever, and you wanted to inherit them from each other. So this is basically how you do that. And there are examples of these on the internet, and it's just shit. And the reason I'm hating about this, I also love this picture because I made this picture. I'm very proud of it. I didn't make it really. I just took a screenshot from South Park. But, I'm proud of it because this was, a parody about inceptions, and this is a parody about a parody, and it's about the union within the union, and whatever. It's late. Let's go. So this is the reason I hate unions. I really do hate them. So this is a very large union, as you can see. And it's basically, the whole union is like 32 bits, I think. I don't remember how large it was. Let's see. Can I use the... Can you see that? I don't remember how you do the pointer thing, but whatever. The third one from the bottom, the second one from the bottom. Yeah, the second one, the eval pointer. It's a union of the same type within the union, you know. And this was like, this fucked with me so much, you know. I spent like 3 weeks doing this, you know, and every time I would rewrite it from scratch, you know, and then run the code, and it would work, and then at some, you know, case, it wouldn't work, and I would hate myself, and I would cry, and this was evil shit. So I'm not sure what the purpose of this union was, but it wasn't really nice. So yeah, this is some stuff somewhere in between. I don't know. I'm gonna skip some of this stuff because the last section is the most interesting one. Yeah. I also made this picture, so I'm very proud of it as well. So yeah, C++, Java doesn't have destructors, which I keep forgetting that is not true actually. Java does have destructors, which is, what's it called? That sucky thing. Finalize. Finalize is a destructor. Nobody uses finalize, which is good. Nobody should ever use it. It's just been recently deprecated, which means it will be removed in 20 years or something. But it's been deprecated. And, but you shouldn't use it. And the reason why you shouldn't use finalize isn't important. But anyways, so destructors basically, it's, for people not very familiar with the concept, it's the opposite of a constructor, which doesn't tell you anything. But you know, the same way the constructor is called at creation, you know, a destructor is called when you destroy the object, yeah? So yeah, why do you need that in Java? You don't need it, of course, because, you know, in Java, the JVM does everything for you, and, you know, everybody lives happily ever after. But in C++, you have to do it, you have to always do it. You have to free memory, you have to free resources and such. And the problem is, some people, like these guys, you know, the Doom guys, they, like, you know, hacked the, the destructor for their own purposes, you know. They put a lot of other stuff in here as well. So this is not all, you know, clearing resources. So if you look at like the fourth or fifth line, stop sound, for example, which has nothing to do with the resources, you know, but it does have something to do with the game, you know. And they put it in destructor because you know you're going to call it destructor, and you want to stop the sound when you destroy the object, which is logical, you know. Yeah. So doing this kind of stuff in Java is actually very easy, you know, but you don't have destructors. That's the point, you know. You want to hand it over to somebody who does all the fancy stuff for you, but in Java you just call a function, which is what I did, whatever. But yeah. So yeah, on the left side, you know, I also mentioned autoclosable ++ because I like autoclosable, which is very curious to me, you know, because finalize has been broken for years, you know. I think it's been broken since Java 0.9 or something. But they've just recently been deprecated. And instead of fixing them, you know, somebody decided, no, we're going to introduce something new, autoclosable, you know, which is awesome, you know, except that using them is kind of sucky, you know. You have to do the whole try, whatever, and implement the interface and that kind of stuff. So yeah. Whew. I'm going to skip this one. Yeah, sorry. Yeah. I usually want to skip this one, but people always, you know, I get a lot of discussion about this one, which is funny. So string stuff in Java is very, string manipulation in Java is, to me, very, yeah. It's just very tedious, you know. So very simple stuff, you know. So here, for example, you want to concatenate hello world into each other with some fancy whatever. And I'm talking about the basic strings, you know, without using string builder or string utils or whatever, you know. So in Java, you know, the simplest way I could write something like this was the ugly line, you know, at the top. And in C++, it's the beautiful, beautiful, beautiful line at the bottom, you know. And every time I you know, tell people this, and somebody comes to me afterwards and says, yeah, but the reason for that is the string is immutable. And my answer is always, but why is string immutable, you know? So I don't really see, okay, so I know why string is immutable actually, but why is only string immutable, you know? Why didn't they make more immutable shit? Why can't we make immutable shit with const like normal people, you know? So yeah, string is immutable, and because string is immutable, you know, we have to do very fancy stuff, you know? And yeah. It's just weird. So this is also one of my favorites. So this, I think the older people in the room might recognize this. So this is also very 90-ish. Back in the old days, you know, you worry about something called CPU cycles. Nowadays, people don't know what CPU cycles are. And something that you waste CPU cycles on is jumping from one function to another function, you know? So when you call a function from within a function, you go to the function, and then you waste something like, because you have to do a lot of stuff, you know? You have to save the current position, you know, of your stack, and then you have to jump to the other function, and then after you're finished with the function, you have to get the old position, you have to jump back. So this wastes something like, I don't know, 10 cycles or whatever, which is nothing, you know, if you were running like 1 million cycles per nanosecond or whatever. I'm not sure how fast things are. So, but in the old days, you had something called inlining, you know, force inline, for example. This is from C++, of course. And you could just basically, if you knew this function was very critical, you could just tell the compiler, hey, inline this shit, yeah? So that's basically, you know, you copy the function and put it within the other function, and it becomes, you don't jump, you know, back and forth. You just, you know, run the whole shit, and that's it. Java has this as well, but the JVM does it for you. And there are a lot of constraints, you know, so I don't remember them all, but something like, it can be more than like 32 instructions, bytes instructions. It has to be called 10,000 times at least, or whatever, and that kind of stuff. And only then, you know, will Java or the hotspot, you know, inline it for you or something. So yeah. It's there, but it's not really there, you know, and it's yeah, it would be nice to have something like this. I think Graal is doing some cool stuff with this. Not sure what yet, but okay. The final section. So yeah, I'm not gonna ask if you know the answer to this one, but so this is like the cool section of the whatever presentation. So because, you know, you have pointers and memory addresses and stuff doesn't move at all in C++ in memory unless you move it, you can just, you know, you have a memory address, you can just watch it, you know. And if somebody accesses that memory place, or, okay, I'm not sure if you can break one at access, but if somebody changes that memory address, you know, you can, you know, the breakpoint goes off, you know. So that's very powerful in C++, you know, and I know you might think you don't need something like that in Java, I know, but you really do, actually, you know. You might not have ever written something big enough or not complicated enough, actually, something ugly enough, let's put it that way, you know. Because, you know, in Java, everybody uses getters and setters, and then they have 1 million lines of code. But, you know, in C++, generally, people don't really use that much, you know, that kind of stuff. So you can't really set a breakpoint in a setter. But, you know, if you have, like, 1 million, okay, 1 million is not correct, but say you have 200 references to the same object, you know, and somebody is changing it, and you don't know who is changing it, you know. This is much easier than setting, I don't know, 200 breakpoints. Sure, you would think, you know, somebody would make something like this for Java, and you would be correct. Java does have something like this. This screenshot is from IntelliJ, because I'm not really sure if any other IDE supports this. Maybe, you know, but this is a field field watch point. I'm not sure what it's called really, hey, yeah. So yeah, if you look at the bottom there, you know, you can define like the field this, and okay, when the field is modified, then break, or when the field is accessed even, which I'm not sure you can do in C++, which I'm not sure why you would do actually. That's something else. But the field modification, you know, then break. But the problem with this, and is that it's very slow. You know, it's like I think 1,000 times slower than a normal breakpoint. So when I sometimes do this, so when I'm debugging the game and the game is running 60 frames per second, for example, I set this breakpoint and it goes to 0.1 frame per second, and it never reaches the breakpoint. You know, the game always, I get bored, you know, after an hour or something. So yeah. But for you know, for enterprise stuff, it works excellent, you know, because yeah, it's whatever, you know, how many iterations do you have in an enterprise application, yeah? So I use it a lot in enterprise, no, not a lot, but I use it in an enterprise application, and there I use it successfully. For the game, I've never used it successfully. I'm gonna skip this one as well, sorry. This is also an awesome feature that I wasn't very familiar with. I knew it existed, but I wasn't very familiar with it, which is basically when you set a breakpoint and you want to go back a couple of steps, you can just drop those frames, you know. That's in Java, which is awesome, you know. The only problem with that is its scope is very limited, so if you change anything outside of the scope of that particular function or functions, depending on how many frames you drop, those things that you change outside of the scope, they aren't reverted, only the things within the scope. So, functional scope, I don't remember what it's called, local variables and that kind of stuff, those are all, of course, destroyed and whatever. So that's awesome, you should use it, everybody should use it. NetBeans has this, and I think Eclipse has it as well, probably, but that kind of stuff. So, and you can do that, and you cannot do that in C++, but what you can do in C++ is you can just reverse step, which is more powerful, actually. So the same way you step into something, you can reverse step out of something, and that really does all the magic and returns everything to the way it should be and whatever. We don't have that in Java. It's also a bit limited. Now it's kind of limited, I've never hit against those limitations in C++, actually, but I've read about people on forums or whatever saying, okay, it's limited with file I/O stuff and whatever, and I think, I don't care, so, but yeah, it's also cool. So yeah, hopefully we'll get that in Java as well. I'm running out of time, so I'm going to skip this a little bit. This is actually cool, so I'm not going to skip this one. So the one I talked about before, during the operator overloading thing, the operator precedence. You would be surprised, how important operator precedence is. So this is a simple example of this exact same operation, but you do them in different order. This only works for floating points and with specific values, of course. And you get two completely different, not completely different, but you get different values at least, And the reason for this is, because floating points are, the precision of floating points is limited, it's 32 bits. And the order you do things in, forces the machine or whatever, the machine, to round up those values first. So here, for example, blah1, the b, divided by c within the brackets is rounded up first and then added to a. But when you do blah2, for example, you round up a times b, and then you divide the result by c. Which might sound trivial, I know. But again, this was a bug I had in the game. So the one blah1, actually, a minus b plus c, within the brackets. This is how the code actually looked in C++. But I was bored, so I rewrote it like blah2, a minus b minus c. Which is mathematically correct, before anybody shouts about it. No, it is mathematically correct. And it works for any other values. That's not correct. It doesn't work for 100% of the values, of course, but these values, it doesn't work at all. So blah1, produced 0, which is the result I actually wanted. But instead of 0, I got the other one, blah2, which I think it has something to do with the speeds of the planet. At the introduction of the game, the planet comes towards you, and it just, so math is important. That's a lesson I learned. And I found this on the internet. It was funny. So building on this, so this is taking this even further, So the one, the examples before were different operations. So these are the same operator, So these are all multiplication, but you just do some brackets and you round up the stuff. And you get different values. And even worse, with addition and subtraction or whatever. You can do this with anything, This is just floating points, And to be fair, this is not Java. Huh? This is how floating points, if any programming language, implements IEEE standard 7.5 whatever, floating points, they have this problem. Anybody has this problem. Big decimal doesn't have this problem because big decimal is theoretically infinite. But good luck if you're going to abuse big decimal in a game, Your game won't run for shit. So yeah, I really love this slide, so I don't want to skip it, but I don't really have much time. So this is something I discovered while doing the game. So this is one of those things but you don't really know. So it's like you heard it at a conference or somebody told you about it, and you think, okay, yeah, I know this. Conditional breakpoints are slow. But until you really do this, you don't really know it. So that's my experience with it, at least. So this is just a very simple benchmark, just measuring, how much time it takes to go over this breakpoint. The one at the top is an ordinary breakpoint, And instead of putting the conditional breakpoint condition within the conditional breakpoint, I just put it in an if statement, and I compile the code. The one at the bottom is a conditional breakpoint, and as you can see, I put the condition there, if I is even, then whatever, yeah? And with my simple benchmark, I'm sure you can get better results with micro-benchmarking tools, which I don't use. With my simple benchmark, it turns out it's about 180 times slower, give or take. And the reason for that, like it says there, is, because when you do conditional breakpoint, your JVM turns back to interpretive mode instead of the other mode, whatever it's called, and it just becomes very slow. And I just started noticing that kind of stuff, and you just get used to, okay, I'm just going to put the if statement really in the code and just recompile it. It's much faster instead of this. So yeah, this is my last slide. I also, I really want to tell this story very fast. Okay. So this was the first time I had the game working. This took me like, I think, a year or something longer than that, something like a year. And this is the introduction video. And my version was the one on the left, the blue one. Okay, now you can see that it's blue, but because this one is next to it. But if I hadn't had this one next to it, you wouldn't notice. And I didn't notice. I really didn't notice. I didn't notice for like 3 weeks. I was so happy, it was working. I don't give a shit. It's just it works correctly, But then I started noticing that it was blue, and I thought it was something very simple. And it took me like, I don't remember, but it took me very long, a couple of weeks to debug it. And this was my first time discovering a bug in in Java itself. And the bug is because I used a lot of byte buffers for this kind of stuff. Apparently, if you didn't know this, when you do a duplicate or a slice, or there's a third one, I don't remember which, when you do that on a byte buffer, duplicate is like a clone. When you do that on a byte buffer, the byte buffer clone, or the new byte buffer, ignores which endianness you chose for the original byte buffer. It always reverts to the default endianness of the machine. So yeah, it just fucks up your colors. So this should be RGBA, and it becomes something like BARG or something. That's why it's so blue. And after a lot of searching, I discovered this is something in Java. And it is kind of documented, and people know that it doesn't work, but they're not going to fix it because backwards compatibility, which is the bane of my existence. So yeah, so I'm going to skip that one, and I'm going to show you the demo, and you can ask questions because the demo takes the time to load, and awkward silence is awkward. Any questions?
Wait, hold on. Everybody can hear your question.
My assistant will
Who?
Oh, there's no sound.
How much slower is Java version compared to C++ version?
I'm sorry, I still can't
How much Java version is slower compared to C++ version?
Which version is required? I think Java 8. Which is not really required. There are a couple of lambdas you can remove.
I asked how much slower it is.
Oh, how much slower? Oh, sorry. Right now, it's not much. The game itself is not much slower, but as you will see, it's not very playable yet. And as you can see, I keep breaking stuff. So I have a couple of videos on YouTube, and this, for example, this should show actually, but in one of my builds, I broke the blending, so it doesn't blend anymore. And this, instead of saying Doom 3, it shows you a block of static, but I don't care. I have more important stuff to fix. So the game itself, as far as it's playable, is not slower, but the loading times are slower. But I think that's mainly because I try to port the code, one-on-one, to make it easier to compare it to the C++ code. And yeah, what's optimized for C++ is really optimized for Java. So that's basically. That's basically the reason. Any other questions? Because we still have some time. Yeah, or comments or whatever, critique.
Question, why did you do that at all?
That's a great question. The talk or the project? The project? The project. Yeah. I don't remember. I honestly don't remember. This is a long time ago. It's like 4 years ago. And to be honest, when I started this, I thought I would be done in 6 months. I thought I would be done porting the code in 2 months. I would get the code working in 2 other months, and I would fix some small bugs in 2 months. 6 months. And I can tell you, after 6 months, I wasn't even done porting the code. I was still porting the code, And yes, I was typing the code over. I wasn't copy-pasting it, because I wanted to learn, which is stupid, I know. But I can skip this, but I'm very proud of this. I can... It's a very complex game, so everything is very complicated in the game. So that video you saw, that's actually rendered with OpenGL, and the text on top of the video is also rendered, and whatever. And yeah, so the reason I show this in wireframe is because the lighting isn't working very well. The game doesn't have any ambient lighting, if anybody knows what it means. So, oh yeah, and I broke the heads, as you can see, but I don't care as well. But... So yeah, if I don't show it in wireframe, it would be too dark to see anything. And hey. Yeah. I'm the guy who created a comedy game out of a horror game, yeah? So... I could skip this as well, but like I said, I'm proud of most of this stuff. So yeah, so it's running okay, I can punch people. Yeah. It also has sound, which I broke at one point, but then I fixed parts of it, and then I don't care about the other parts, that kind of stuff. Yeah, this kind of stuff. I really love this part because no, really, it's about game mechanics, So. Because you can see wireframes and such, you can see everything behind the door isn't rendered yet until the door is opened. This is something to do with BSPs and whatever and that kind of stuff. And yeah, okay, so this takes a while, and I'm really out of time. So I'm going to do this, which also, this works, yeah, and I'm going to do this kill, and I'm dead. So thank you very much.